This conference will now be recorded.
Hope you're all able to see my screen. So anybody confirm? Are you able to see my screen?
Yes, I able to see the screen.
Okay, thank you. So yesterday we have installed our application using Docker Compose, right? So it is ready now. It's prepared now. Now let us launch it. Okay. What is the port number? 8080. Okay. I just set it up. So our application is running over here. Yesterday we saw this actually. Okay. So suppose I am adding some data, some problem, something we have not completed yesterday. Uh, that is about, we have not discussed about another topic called bind volume, where it is. Yeah, bind mounts. So we have saw anonymous volumes will not have any name. Actually the system will create the Docker will create the anonymous volumes, where we can see it: cd lib var lib slash docker slash volumes ls. So here these are all, whatever you are seeing are called anonymous volumes. These volumes does not have any, will not have any names, will not have any names. These are called anonymous volumes. And yesterday we have created volumes. In that volumes we have named volumes we created yesterday. In that we have created some files xyz 1 2 3 like that, we attach to it, right? So those are called named volumes. You can create your own volume, right? So docker volume hyphen help. So where it is, spelling mistake. So if you want to create your own volume, you can create your own volume. Those are called named volumes. Those are called named volumes, right? Now the last one is bind mounts. Bind mounts, when to use bind mounts. Suppose you want to bind your container volume data to a folder which is created on the host machine. For example, this root IP address using that, this is a host machine, right? This is your Linux machine. This is your Linux, Amazon Linux machine. I can create a folder here on my Linux machine. To that folder, I can bind my containers data to my folder which is running on my host machine. So whenever you want to bind volumes with your host, with the directories which are on the host machine, then those are called bind mounts. So when we can use bind mounts, so that is, let us see with an example. For example, yesterday we have created some application something like this, right? Right. So two items I will create here. Two items I have created. Now you know where it is stored, where these are stored. You know these are stored in the database. That is fine. But its information will not be stored permanently, because if I shut down my application, my containers, then this data will be lost. this data will be lost. So how to shut down? Yesterday we have not worked on the process of shutting down the containers. So we have used how to start our application using Docker Compose. We worked yesterday. That is Docker Compose up, and I want to detach from it. So up will take care. Up will automatically, it will do two things. One thing is Docker run, and Docker run your application name. What is your application? Your image name, right? Image, and it will detach from there. After that, it will detach. This one image one, right? This is your application main image. This will, and it will run another run command for your database, for your MySQL. For MySQL, it will run for, it will create one more image. Two images will be two images will be executed inside a container. So Docker will create two containers. In each container, it will deploy the application image and your database image. Both will be running. So first, but that in a Docker Compose, we informed that first create the, what we informed, first create the something happening here. I'm not opening the morning. Some problem here. No problem. So if you say Docker Compose, cd.ls cd amazon ls cat docker, you see here we are clearly mentioning it depends on this particular container. So your Docker will understand, sorry, Docker Compose understands that it will create first this database, and then it will create the new container for running the image, for the application image inside the container. So systematically your Docker Compose will create the instances with only one command, that is up command. One up command will take care of everything. So this Docker Compose will read the Docker Compose file, and as per the instructions, it will execute. Right. So how to terminate the containers? Yesterday we see these things. How to terminate the instant containers? We can terminate using down command. When you set down, all the containers, even there are 100 containers, all the containers will be shut down. If you want to stop a container, you can use stop command. If you want to start, you can use start. In Docker also we have. In Docker also we can stop. Same command. We can use start for starting a container. So Docker Compose will stop all the containers. If there are 100 containers, all containers will be stopped and started. Right? One moment, please. Fine. So today, what problem we are going to solve to persist the data. To persist the data. For example, if I run this command Docker Compose, for example, what I will do, Docker Compose down. Now you see it is removing the containers. It is removing the containers. Okay, along with the network, everything, whatever it has created, everything is cleaned up now. Now, if I go to my application now, it should not be running. If I refresh, yes, continue. Anyway, container is not running. Let me start it again. Okay, up and detach. So first network is created, next your DB container is created, and next your application is created. Now your application should be running. Now let me refresh it again. Continue. Control C. Let me remove it. Paste here again. But you see there is no data. The items laptop and RIN, the items which products which I have entered, those are lost now. Those are removed from the database. So if applications does not persist the data, then in real time the applications are useless. So that is the reason we have to make the container stateful using bind mount. Okay. Docker containers can be made as stateful using bind mount volume, bind mount volume type. Okay, this type you can use. Okay, that is one thing. For that, what we have to create? For that, what we have to create? For that, first of all, we have to create a directory on our host machine. Okay, something like make dir, something like data. You can create a folder like make data. So let me create here cd clear the screen. Let me terminate my machine, my servers down. Okay, this is command will not work. It will work wherever your Docker Compose is there. Only there you have to run the command. Okay, so for that cd Amazon. What is Amazon folder? I have just now pulled it. I pulled it from my GitHub. So you also have to do the same thing. One minute, please. Now it's stopping now. Now come out of it. Create a folder called data. Right now, go to your Amazon folder again. Here I have to modify. I have to change the. I have to bind the my physical folder that is which is created on my physical machine or my host machine. So where I can do the change vi compose.yaml file. Here scroll down, go to insert mode. Here we have to mention, so the database having the data, right? So for the database container, what we have to say is that under volume section, we have to map, we have to bind that our to bind to our folder which we have created slash data, not slash data exactly, relative path. We have to give relative path dot slash. It will check wherever data is there folder, it will check with that name and a colon here. And wherever MySQL stores its data by default, it stores its data by default in var folder, var lib folder. In that your MySQL will be there. So here I'm saying dot slash data. That means here one more extra slash is there. That let me remove it. So I'm telling to Docker Compose that I have a folder on my physical machine, on my host machine. Okay, on my host machine I have a folder with name data. So bind that my MySQL database to that data, so that even when we shut down the containers, the data still available when you again launch the containers back. You will not lose the data by doing this. This is called bind mount. Okay, escape and save it. Now let us run the file again. Docker compose up and detach. Now it is running now. Let us try to launch the application. Enter. It's taking some time to connect to the database. Yeah. Now here I will say item 1. Okay. Some A1, and here I will say some 1000. Submit. Item 2 B1 some 2000. Submit. These two items I have created now, right? Then what I will do, I will shut it down. So Docker compose down. Now they are down now. So my expectation is that my data should be persisted to my binded folder, my folder which I created on my host machine. So when I close this, when I up it again, remove now. When I up it again, then my data should be shown again. Whatever data I entered before, that should be persisted and should be displayed in my application, so that it can be usable for others. you see our items are persisted. Item 1, item 2 are still available, right? So in the interview, if they ask you what are different types of volumes, what are the use of them, so please try to explain them because you have seen this practically. So in the while when you know the answers, then you have to answer them very confidently. When you don't know the answers, no problem, yeah, they will understand. But whatever you know, you have to explain them perfectly. At least you should score more marks there over there. Same like which we did in our examinations also, we do the same thing, right? So same thing. So we should not lose the opportunity. If you get a question which you know very well, you should answer them very elaborately with examples. Anyway, I'm shutting it down. Right. So one important topic going to discuss, that is Docker Swarm. Docker Swarm. So actually, Docker Swarm is uh, what do you call? Is a orchestration platform. It's an orchestration platform. Orchestration platform is what? It will handle hundreds of containers. It will handle hundreds of containers. Handle hundreds of containers means what? Why it has to handle? See, normally we will not create containers on only one single machine, right? On one single machine. Just now how we created now. That way we won't create. That way we won't create. In real time, there will be multiple servers. There will be multiple servers. On each server, containers will be running. So one container will not be running on only one machine. It will be running. So one application will be running in easily 20 to 30 containers. And I believe you know why our application should be running in multiple containers. I have explained you from the beginning, if you remember. Amazon application is there. Amazon application should be running in multiple servers, I used to say. Why also example also given, a restaurant example also given. If more customers coming, then you should have more servers in that hotel, right? Similarly, if Amazon having a lot of customers every day, so more servers should be there running the same application. If one server is down or crashed, then remaining servers will take care of the orders, new orders coming from the internet. Hope you know those things. So similar way, your containers are nothing but your virtual machines, like your virtual machines only, or like your servers only. Don't confuse. When I say containers, you just map them with the name servers. Container servers both are same terminology wise, maybe not same technology wise, they are different, but nothing but the containers are serving some application, right? We can say them as servers. They are serving application running inside the container. So if your application, that is the reason your application will be running in like it will running in multiple servers. Similarly, your application also should be running in multiple containers. And virtual machines, they will be running in different data centers, and in the different data centers and different machines they will run. Why? If something happens to a data center, then the customers will be routed automatically to another data center if there are any issues with the network in one of the data center. So that means applications not only running in different servers, they are also running in different data centers also, remember, in real time. So there are many challenges to tackle. So similarly, containers also should be running in multiple servers. They are also running in multiple servers. Why? If all the containers, suppose I want my application should be running in 20 containers, and these 20 containers running on the same node, same machine, same server, for example. If something happens to the server, all my 20 containers will be crashed. All my 20 servers will be crashed, and my application will not be available to the customers which are running inside the container. That is the reason normally there will be different applications, and every application will be running in easily 20 to 30 containers, and these containers will be running in multiple servers. There would be 10, 15 servers, 20 servers, 30 servers on each server, or I should say node. I should say node or physical machine. On each physical machine, your containers will be running. There will be multiple the same application running in 20 containers are spread onto multiple physical machines. On each physical machine, on some physical machines, some 4 containers will be running. Another node, another physical machine, there are another 5 containers will be running, which are belonging to the same application. So this way, if anything happens to one server, no problem. Your application, your container is running on another server as well, right? Another node also, right? Another physical machine node are same. Okay. So this way, they will be running on multiple nodes. So when your containers are running on multiple nodes, then manually, as a DevOps engineer, we cannot we cannot maintain them, like create 4 containers here, 4 containers on that machine, 4 containers on this machine. So while doing that, we also understand capacity of the node or server physical machine. What is the capacity? Already it having enough containers running in that. If there are it is already having enough containers, then I cannot run my containers, new containers on that node. I should select another node. So all these activities we cannot do it manually. So for that we use Docker Swarm. Docker Swarm, what it will take care is, it will take care of creating containers on multiple nodes. It will take care of creating your containers on multiple nodes, which we cannot do when the size of nodes increases, when the number of containers increases, number of nodes increases. Manually doing is very much time taking process and error prone. That is the reason we go with Docker Swarm. Okay. So because it is managing these containers on different nodes, then we can say it as a orchestration tool or container orchestration platform, because it is orchestration. So orchestration, right? And in maybe not in India, yeah, here also we'll see that, no? A guy a guy which holding a stick, and he waves the stick in the air, and accordingly the different instruments, the players using different instruments, they play accordingly, right? So people playing using different instruments, and as per the person who waving it, as per that they will uh, play their instruments. So here we can compare those instruments with our containers. Those instruments are different instruments, nothing but different containers having different applications, right? The person who waving and controlling all the players, so that person we can say him as a orchestrator. He's an orchestrator who managing all these players. Similarly, Docker Swarm is a orchestrator who manages all the containers. All these containers contain different applications, like different players playing different instruments. Similarly, these are different containers, they're having their own applications in them, like that. So that is the reason we call this tool as orchestration tool. It is a container orchestration platform. Okay. So orchestration, as I told you, orchestration means managing multiple containers. So Docker Swarm is used to set up Docker. We use a new term called cluster. Cluster means what? Collection of nodes. Cluster means collection of nodes. If there are more than one, we call them as cluster. If we have one data center, if you have two data centers, then we can say uh, this cluster contains two data centers. If you say we have 10 servers, physical machines connected together using LAN network, then we can say in this cluster we have 10 nodes connected. That way, cluster means it can be any group. It can be any group. In our case, cluster means group of servers. Okay, meanwhile, let me do one thing. Right. So, and here actually in this cluster, it will be something like this. When you install, so no need to install any software from Docker Swarm. When you install Docker, automatically uh, we can use Docker Swarm. So these are different containers. Assume we have two containers here as of now. So there are three containers. This is your master node. We call it as a master node where your Docker Swarm is running. So this is a EC2 instance. This is EC2 instance. This one EC2 instance where your Swarm, which the orchestrator is running here, and this is your another EC2 where the containers can be executed. Even on master node also we can execute containers. So this master node now it will control these containers. So suppose these containers are running on different machines. You see, they are running on different. So this EC2 instance can have any number of containers. It can have any number of containers. This is a machine, EC2 machine. In this machine, you can have multiple containers. That decides by the master, your SWAM, Docker SWAM. Docker SWAM decides how many containers should be running on each machine, depending on its hardware infrastructure capacity. Suppose Docker master node also can have in containers here. So whenever what happens is it works like a round robin algorithm, it works like that. That means initially master node do what? It will install the container on his machine, on his own machine, and another container. If you want a second container, then it will create a second container on the another node. This is a node one. No, this you can say it as node one, node two, like that. This is a node one. I should say node one or physical machine, node one, and this is node two. So master node will create, suppose you want to deploy containers now. When you want to deploy containers, then master node will deploy the containers on its machine. Once on its machine one container is deployed, then it will deploy second machine on another container. And when you create a third container, you want third container, then that will be created on the second machine. Since we have only three machines here, so when you create fourth one, the fourth one will go to your master node, and the fifth one will go to your another node one, sixth one go to node two. Like that, round robin fashion, it will create the containers. So if you have 10 containers, then all the 10 containers will be filled first, and again if you have more containers, 11th 12th, then it comes to the first container. Like that, it fills the containers, it creates the containers in a round robin fashion. Okay, so these are nothing but your worker nodes. This is your master node. So you have to install your master. You have some commands to create to make this container as a master node. We have some commands. When you run the commands, we can make this container as a master node. And when it becomes a master node, then we have to join these containers, which are worker nodes, to this master node. When they are joined to this master node, now your master node can able to control these two machines. If I want to install any, what do you call, any containers, I want it, if master node want to create any containers, then it can automatically connect to that different machine, and it will create a container inside that machine. And it also similarly it connects to another machine, and it will create the container in that machine. So before that, what we have to do, before that we have to make this container as master node, and then we have to use few commands. That command should be executed on each machine. So first, when you made this machine as a master node, then that command will give you a command. It will produce you a command. That command you have to copy and paste, and you have to run on each machine. If you have 10 machines, you have to run that on 10 machines. When you run those command on 10 machines, all those machines will join with your master node. Automatically they will join with your master node. Once they are joined with your master node, then your master node can able to communicate with your containers, right? Okay, we will set up master and worker nodes using Docker Swarm. Master node will schedule the tasks like our Jenkins. In Jenkins, we have master slave nodes, right? Same task. Task means here creating the containers. Task means creating the containers and manage the nodes. Nodes means your EC2 instances. Here EC2 instances, or we can call it as virtual machines, or we can call it as a servers also, right? Many are there, but end of the day, you should understand the concept. Then whatever name you give, you will not confuse. Okay, and node failures. If any failure on the node, if suppose this node is not running, if this node having some issue, this server is not running, then your master node will not create containers over there. It will create the containers in other nodes. Worker nodes will perform the actions based on master node instructions. So as I told you, Docker Swarm, to use Docker Swarm orchestration tool, we don't need to install it anything separately. It is already embedded. It's already available. Is already available in Docker Engine. Docker Engine, you know what is Docker Engine? We install Docker, right? When you install Docker, Docker Engine will be installed, right? Docker daemon, Docker Engine, all are same, right? So Swarm, Docker Swarm features. So it will manage the cluster, right? Cluster means the nodes inside the network. Cluster management, and what else? Scaling. If you scale means if you want containers, I want to 2 containers, 3 containers, 4 containers, 10 containers. How many containers you want? You can inform to Swarm and Docker Swarm, and Docker Swarm will automatically create those number of containers automatically, and it also take load balancing. So many more actually, etc. So how to set up? How to set up Docker Swarm cluster setup? So first of all, let us create. Okay, first we need to create one master. We let us take one master and 2 nodes. For that we require 3 instances, 3 EC2 instances. Create 3 EC2 instances. Okay, you take Ubuntu or Amazon Linux, no problem. I will take Amazon Linux. Okay, and install Docker in all the 3 machines, 3 instances I can say. Okay, perfect. That is one step. Second step is, because we are going to create 3 instances, and 3 instances at a time we are creating, and 3 will be having same security group, and in the security group we have to add a port number 2377. So this port your Docker Swarm uses to communicate with your nodes. Okay, add port 2377 in security group of all the three instances. So if it is same instance, same security group, if you do one security group, it is applies to all the three, right? It applies to all, right? So that is the reason. Please try to understand. The security group should be same for all the three. If they are different, also no problem, but they should have this port number 2377. Okay, I will remove this in security group, assuming all three instances having common security group. Okay, so in security group, okay, so that Docker Swarm can communicate with the cluster or with the nodes in the cluster, or I can say worker nodes with the worker nodes, right? So finally what we have, we'll have one master node, another will be your worker node, right? Worker nodes can be any number, but master will be only one. You can have multiple masters also as per your requirement. You can have two masters, three masters, four masters, and each master will be handling different cluster. Okay, that depends again your project requirement. Okay, right. So let's complete this step and come back. We need three servers. Here number of instances are three. Docker Linux, Amazon Linux. Security group name, let me change this name. Okay, already I have multiple security groups. Let me change this name. Okay, I'll say Docker Swarm SG. Right now launch instances. See, I have selected three. Launch three. All three are running. Okay, let me name them as this as master and this as node 1. Right, three nodes are there. So select one of the node and go to security. Click on this Docker Swarm SG 8 inbound. Right. So what is the port number we have to add? 2377. This port number we have to add 2377, and here select anywhere. Now save this. Since all the instances having the same security group, so this will be applied to everyone. Let us connect all these three nodes now. Okay, select the first node, master node. Here open a new terminal. In terminal, right click and paste. Yes. Here what we have to do, sudo -i hostname master, right? This master node. Here, let me create one more node, that is node 1. Oh, it by default it going here. So here also sudo -i. Now the last node, so ping dot google. Before that, there are three nodes now. This is a master node. Here we have to install Docker, right? So for that, yum install Docker -y, right? This we have to install. You also have to install on 3 machines. After that, what we have to do? We have to start the service. Service Docker start. Right, on 3 machines it is running now. Service is running now. Okay. So ping google.com node 1, ping google.com, this one as well. Now our setup is ready. Ping google.com. 3 servers are ready now. Okay, fine. Next, what we have to do? As per this, 3 instances are ready now. Docker is installed on the 3 machines. So now what next remaining is, I have to make one of the node as master. You can pick anyone, no problem. Okay, you can pick anyone. But how can I make it as a master node? Initialize a Docker. What do you call? Yeah. Initialize a Docker. No, initialize a run below command to initialize a instance, a server, a node to be to make initialize a node to be a master node. So this is the following command we have to run to make one of the instance as a master node. Run below command to initialize and create the master node. This may be better. Initialize and create the master. So what is the command? We have to say Docker, and here we have used the run command. Okay, we have used build command. Many are there, right? One of them is swam command. This is another command, swam. So Docker is our client program. Swam is a command. Now this swam command goes to your Docker engine. I'm telling to Docker engine. I want to create a Docker swam. So I want to make this one as a master node. So initialize it, init. I should say init, Docker swam init, and we have to run a command called advertise address. So I have to give this node is my master node. For that, I have to give my master nodes private IP address. I have to advertise. I have to tell to my Docker engine saying that this is my master node and its master node's IP address is this one. Then we have to provide the private IP address. So advertise address ADR and your private IP address. Normally, private IP address. You have to provide it. Don't give public IP address. Right? This way. So what is our private IP address? Our machine. This is my master node, right? This is my private IP. Select it, not the public. This way I have to give. Copy this command. Go to my master node. This is my first node is master node. See your master. I have typed your master. Okay. Clear the screen. Run. You see SWAM initialized. Current node is now a manager. To add a worker to the SWAM, run the following command. This is a command. Docker SWAM join. Right? So this you ignore it. But this is a command we have to run on these three machines. On these three machines. Okay, copy this. Right? Then what I have to do? So run what do you call, or else copy the, what is this? It's a token. It's a token. Okay, it's a token. So copy the token and execute in all the worker nodes so that they can join with the master node. Okay. So example, this example. Okay, this example. So don't use this one. For you, you will get a new token when you do this. So go to my, this is my master node and this is my two nodes, other two nodes, right? Click on the second tab, Control C. This is my node 1. Okay, paste here. What it's saying, this node joined a swarm as a worker. It joined to a swarm as a worker. It is running fine. And let us do the same with other one. Control C is node 2. You see it's node 2. Press enter. This node joined as a swarm as a worker. Any questions till now? Right. So before I get into more commands, these are the basics things. Okay, basics things. So one important thing we have to do here. What is that important thing is, when you're working with Docker Swarm, we have to always pull the images from your, what do you call, your hub, Docker hub. Today this one is not working for me. Docker hub. See, some problem is coming. No problem. I will take care of this later. Let us use my browser. You go to Docker Swarm, sorry, Docker hub, because end of the day, what we are trying to do, we have to run the container. Okay, but container contains what? Image. Where is the image available? You should always pull it from the from your Docker hub, not from your local. Okay, sign in here. Always better you create your own account. Okay, see, I have two images. One is React application, one is Java application, that is shopping site. I will pull this image. Okay, but before before that, what we have to do, you have to understand these containers. your worker container, sorry, your master node will, I'm typing else so that I will not ex, ex lost the session. Some commands I'm running like that. So before I go any further, first thing I have to clear few things. That is, you have to prepare the connection with your Docker hub. You have to create the connection with your Docker hub, because when this master informs to one of its worker node that you have to run a image, you have to run a image name is this, then your worker node will check whether the Docker engine's image pool having that image or not. If it does not have, it will connect it to your Docker hub. So for that, what we have to do is, whenever it is try to connect, it cannot connect. Why? Because your worker nodes does not know how to connect to your Docker hub. So for that reason, in each of the container, sorry, in each of our worker node, we have to log into your Docker hub. You have to be prepared before you start your Docker swarm. You have to log in to your Docker hub before you do any operations. Right? For that, what you have to do? You have to use Docker login, which we did before. Before, how to know how to push, how to pull images from Docker hub, we did this. Docker hub login, Docker hub. I am doing on master machine. The same thing I have to do on every machine. Here is username Madan DevOps 2024 is the username. This is username. Don't give at the red Gmail. This is username. How to know the username? When you create your account, you will get your username here. Click on your logo here on the right side. You will get the name here. Use this is username and your password. Enter here and enter your password. Now login succeeded. The same thing you have to do on each node. So that, because these will connect automatically to your Docker hub whenever they require any image. So it is also fine. Right, all are running fine. Let me ping Google again. I don't have work here now, any moment. Let them run backend. Now I am back to my machine. This is my master node now. Now, do you remember in Docker Compose? In Docker Compose, what we did? Under services section, where is that? It will take another maximum 10 minutes. Just give some time. Services, you see, in the Docker Compose file syntax, services. Services represents our containers. Services represents our containers. Docker Swarm also uses services. Services is used to serve the images. Like in the Docker, in your Docker Compose file, under services, we have mentioned our image names, right? Similarly, in Docker Swarm also, we use the services to serve our images. Okay. For that, how to uh, run the command then? Okay. Let me see that. How to use the services, because we are not using Docker Compose, but in Docker Swarm, how can we use it? Okay. So Docker Swarm service. Service is a collection of one or more containers of same image. If you want different containers, different images, you have to create another service for that. Okay. Escape. There are there are two types of services in Docker Swarm. One is replica. Replica is the default mode. It's a by default, it will take default mode. Replica means how many containers you want. Mostly we use replicas, and another is global. So how to use the services? Dollar sudo already you are a user, root user. If you are not a root user, you have to use sudo docker and service. Okay, docker service, like docker swarm, docker run, docker build, like the docker service is a command. Now you are going to create a create docker volume create, docker network create, docker service create, like that. Everything is same. And what name you want to give? Hyphen name of the service, name of the service. And what is the port number of your image? So as I told you, first one will be your host port colon, the other will be your container port, right? And then your image name. This is the syntax. The same syntax we have to use for creating our container now. Okay. Now how can I do it? Now you see dollar docker service create hyphen n. I will say I will want to create a service called shopping site service. Some name I want to give, shopping site service, any name you can give. So port number, our application is running on port number 8080, 8080 colon 8080, right? Where is my image available? Docker account name, that is Madan DevOps 2024 Amazon store. It's Amazon store is different one. And this is, what is that? What is the name of our shopping site? This name you have to give, shopping site, right? This command you have to use. When you run this command, where you have to run this command? Only on your master node. Run only on the master node. Okay, this you should understand. Not on the slave nodes or not on the worker nodes, because worker nodes your master node will take care, right? Let me run this. Is a, yeah, clear the screen. Now run this command. What is said? Unknown flag n in n. Why it is? Oh, it should be name, right? I have not typed name. It should be name. What happened? Docker service create. Uh, Only one hyphen given. It should be two hyphens. Give it two hyphens. Save this file. You see, this is your service ID. Overall progress 0 out of 1 task preparing. It is trying to pull our image from our Docker Hub. It is preparing now. Waiting 2 seconds to verify the tasks are stable. Service converged. That means your service is ready now. Now you can access your application now. It is ready now. It is ready. It is served now. So let us see first of all whether the service, that is whether how to see the service running with the check whether service is available or not. How to do that? Docker service ls, docker service ls. You see ID, this ID, same ID, it is ID of the service, name of the service, replicated. How many replicas? And that means how many containers are running? Only one container is running. One container and one container is running. So available on port number 8080. So how can I access it? How can I access the application? Okay, we can access our application using below URL. So how do you, what is the path? HTTP is not required actually, but no any problem. HTTP and your master node public IP, right? And then colon your port number 8080. Okay, let us try that. What is your master node IP address? This is a master node. This is a public IP. Let me run here. Colon 8080. And it's a Tomcat application, right? You know how the Tomcat application runs. We have to give the application name as well at the end, right? So for that, I should know the application name. And where is our application? My GitHub is not working. Anybody downloaded that code? GitHub sign in. So where is our application? Here it is. I think this is the one. Is this one? Yeah. Go to pom.xml. This is your application name. Shopping site web app. All right. This is the name you have to append at the end. If it is an Apache application. Sorry, if it is a Tomcat deployed on the Tomcat. Enter. Still not working. Okay. Let me check where my application is running, in which container my application is running, because we have three nodes, right? I'm given my public IP of my master node, right? I'm expecting it is running in my master node, but let me check where exactly the our container is deployed. How to check that? So for that, maybe it's not running on my master node, right? So then inspect, or not inspect, like you see containers, how to, you'll say docker ps hyphen a, you do, right? The same thing how can you do with your services? Verify service details. Then you can use docker service and a service name. So for that I have to use what? Dollar docker service, and service name is what? What is service name? What is service name given here? This is a service name. This is a command we have to give. Then it will show you where our container is running with IP address. Let us check that. It is showing our service is running. Uh, Latest master. Yeah, it's showing on master node only. It's running on master node only. Okay, running 5 minutes ago. Then why it's not? Let me open it in Chrome. Let us take again our public IP. 8080 slash. Okay. Should be coming by now, but it's not coming. Oh, I'm sorry. We are not added 8080. Nobody is saying, no? Nobody is telling about adding about our port number, right? I have to add port number 80, right? You are not informing. 8080 anywhere. Save rules, right? Now it should come now. Okay, enter. You see our port is deployed now. So about these are application deployed now. Okay. Now our application is deployed. Suppose only one container is running. As of now, only it is running on only one replica. Only one container is running. Suppose what if I want to deploy more containers? Don't try with more than 3 because we are using T2 micro. If you're using T2 medium, then you can try more replicas, more containers you can create. It will hang if you try more containers, it will hang, right? That is a problem. So for that reason, let us play with the 2 and then 3 slowly will play because this will hang at any time. But anyway, one important thing, what is that? And here you should say definitely add required port number as per the application that we deployed. If you are deploying React application, then we have to use port number 3000. If it's Python 5000, like that. Add required port number as per the application that we deployed in the security group. Okay, please do not forget. I too forgot it. Now, next is how to add more replicas. That is scaling up. We can scale Docker service. We can scale multiple containers using Docker service. How to do that? Docker service scale and a service name. The service name which we just now given, right? Above service name equal to, okay, number of replicas. How many you want? How many containers you want? Those many you can mention. That means dollar Docker service name we just now created. This is a service name shopping site service equal to, I want 2 containers. Okay, 2 equal to 2. Run this. Enter. Before that I run, let me check the remaining are running. Yeah, it is running. It is also running. Fine. Okay, what is the problem? Docker service. It is saying a Docker service command shopping site uh, scale. Where is the scale command? We have not mentioned scale command itself. right? Docker service scale. So it is giving use scale here. Use is scale. Scale one or multiple replicated service. If you want to scale, you can use it. So various other commands available. You can try with those. You have to give scale. Now you see it's scaled to 2 and one is running already. It is already one is running, so it is not touching it. But the second one it is preparing now. It is preparing means what? It is getting from the image pool or it is getting from the Docker Hub. Two containers are running now. Waiting 2 seconds to verify that tasks are stable. Yeah, those are stable now. So how to check now number of containers running? Docker service PS site service exception site. See now two containers. One is on running on master node, another is running on node 1. You see, automatically it created another node on node 1, right? So if you go here, this is node 1, this is node 2. If you go to node 2, for example, if you say docker ps-a, you can use same command, docker command. You see no containers are there here, no containers are running here. But if node 1 we have created, just now master node has created. Let us check that docker ps-a. You see a container is running. About 45 seconds ago it is running on this container, right? Like that you can create the master will take care about creating the containers. Now go to your what is that uh, instances. Now your this is docker and refresh. This is node 1. Select your node 1 public IP. Now this time public IP 8080, and then your what is this shopping site app, enter. So now it is a different container. Now it is on one ending with 91 133 is a public IP, and this is with 7662 different public IPs, right? So similarly you can, obviously by now you understood what we have to do. Similarly you can scale it up to 3 as well. 3. Now already 2 are running. Now third one is preparing now. Just give me 3-4 minutes. Almost done. So now if you run the previous commands now, okay, this one. Now you see master node 1 on node 2 also running now. It is deployed on node 2 as well. When I go now, when I increase it to 4, it will create one more on the master node itself as a round robin fashion. But be careful. If you do fourth replica, your system may hang and no commands you cannot execute commands. It will hang now at that time if you're creating more containers. So for that you have to use D2 medium or something else if you want to try. But anyway, node 2 is ready now. So previously in node 2 we don't have any containers now. Control C. Now here also one container is running now. You know how to access it. Okay, you access it. Next command is, now anyway we have done the job. Then next thing, I want to come out of this group. I have to leave from this swarm. Okay, then what you have to do? Remove one node or more from the swarm cluster. Suppose if you want to come out of it, then what command we have to use? Then we have to use docker swarm leave. And similarly, finally, you want to remove a service itself. The service itself you want to remove. Then docker service, remove the docker service. Then what you have to do? Docker service remove rm and the service name. Right? These things. Okay. Let me run this first thing. When I run this one, then all the containers should be terminated. When the service is removed, then the containers also should be terminated. What it's saying? Oh, I am running on worker on node 2, right? I should not do that. And I should run on main master node. Run it on master node. Shopping set, it's stopping now. So what is the command? Previous command. Let's see this. So no such services. Everything is removed now. Now if you want to leave, then Control C. From the master node you want to leave, then use Docker swarm leave. And before that, do you have any containers running in this? No containers are running because our service terminated. Then all the running instances also removed. Images containers also terminated automatically. Then leave swarm leave. Node left the swarm. Node left the swarm. Right? So you please change the order this way. First you remove it and then you leave the right. Finally, that's all. So I will end the session today, and tomorrow we will start with Kubernetes. Tomorrow we will starting with Kubernetes, and nowadays in the market Docker Swarm is not used, so most of the companies are using Kubernetes. So just to try to make you understand how the orchestration works, yeah, it's like introduction to Kubernetes only. So the Kubernetes is completely different. You cannot run containers on your master node like we did doing here. Okay, please practice these things. Tomorrow we will join at same time. If you have any questions, tomorrow we'll continue. If you have any doubts, let me ask tomorrow. Okay, take care. Thank you for your time. Have a good day.